Okay, here we go, intermediate algebra students, with section 9.4, where we will be solving quadratic equations using square roots. Yesterday, we learned how to simplify square roots, so I want you to take a minute to pause the video and make sure you feel good about this concept. When you have these two problems answered, unpause to see how you did. All right, when I see square root of 98, I try to think of perfect squares, and I realize that it is divisible by 49, because 98 is 49 times 2. What we learned is that if we can break it apart as that, then we can look at it as the square root of 49 times the square root of 2, and the square root of 49 is 7. So you should have gotten 7 root 2. Now, as you guys keep progressing through this, there's a chance you may jump from here to your answer, and that's totally fine. All right, the second one, we had to multiply two radicals. So we talked about if there's numbers in front, we multiply those together outside. And then we take the things under the radicals, and those will be multiplied together inside. We also talked about how you are allowed to multiply the 6 times 12, but then you get a big number that you have to think about perfect squares for anyways. Instead, I can actually just break down the 12. So first I'm going to do 4 times 3, which is 12 in front. The 6 I just put under the radical, but I know that 12 is 6 times 2. So I change it to that because we also learned yesterday that if you ever have two of the same number multiplied by each other under a square root, that's going to come outside. So we have 12 times 6 root 2, and 12 times 6 is 72. So you should have had 72 root 2. Now, the whole reason for section 9.3 is the only section this chapter that wasn't solving quadratics, and that's because we needed to get this skill. We had to learn how to simplify square roots, so that today when we solve by taking square roots, we can simplify our answers. So here's what we're going to do. We're going to do 3 different layers of solving equations by taking the square root. The first is the most basic form. If you just have x squared equal to a number, we're going to find the solutions. Now remember, solutions are what can x equal. So when I look at number 1 and it says, what are the solutions of the equation x squared equals 49? The first thing I think about is that I understand an exponent means you're multiplying the number by itself, in this case 2 times, because that's the exponent. And because we're doing quadratics, it's always going to be 2 times because we're always going to be dealing with x squareds. That means that I'm actually thinking of two numbers that when a number that when I multiply it times itself, I get 49. Well, right away I think about 7. And so I know that 7 times 7 equals 49. So an answer is x equals 7. But here's where we have to be careful. When we're talking about a square, multiplying something by itself, we have to remember that two negatives times each other also equal a positive. So isn't it true that if I do negative 7 times negative 7, I also get 49? Because a negative times a negative is positive. So for these problems, you are actually going to get two solutions, a positive and a negative. Now, let me write it out the way we're actually going to think about it. This is why it works the way it does. When we solve and have x squared by itself, anytime you have the piece that's squared all by itself, the strategy we can use is to take the square root of both sides. But when we do that, so it cancels out the square here, and we get x equals, but it's the plus or minus square root of 49. So when you solve by taking the square root of both sides, you have to include the positive and negative answer. And this is the symbol for the positive and negative version of an answer. Now I get x equals plus or minus 7. Pearson does have this symbol in the toolbar, so you could write it as the plus or minus symbol 7. When you click on the box to enter your answer, this symbol pops up. Or you could type it as 7 comma negative 7. Either one will work. Okay, so when it's just x squared equals a, x squared equals a number, you can just take the square root of both sides. Now let's look at number 2. What about x squared equals negative 121? Well, when I take the square root of both sides, this cancels this out, but I get x equals the square root of a negative number. So we're trying to think of two numbers times itself that give me a negative. That can't happen. I can never multiply two numbers together, the exact same numbers, and end up with a negative, because if I have two positives, it's positive, and two negatives gives me a positive. Therefore, if you ever get this case where you have an x squared equal to a negative number, because we're trying to take the square root of both sides and we can't take the square root of negatives, your answer is no solution. Just like when we graphed, we had a picture where the quadratic or the parabola did not cross the x-axis. Now, technically speaking, it's no real solutions. I can't remember if Pearson puts that in there. Eventually, you'll learn about these things called imaginary solutions, but that comes later. Okay, so just no solutions would be sufficient for now, but understanding that it's actually no real solutions could be important in the future. So that's the most basic level. If you have x squared equals a number, square root both sides. Don't forget, when it is a nice square, you take a plus or minus, and if you're taking the square root of a negative, it doesn't work, no solutions. So pause the video and try these two on your own. Hopefully what you found is that when you took the square root of both sides of this one, you got plus or minus the square root of 169, and the square root of 169 is 13. Okay, 13 times 13 is 169. When you went to do number 2 and you went to square root both sides, you had the square root of a negative, and that can't be done. So that one was no solutions. Now, if you understand this concept, you're going to be just fine today, but we have to add in some other basic algebra steps. Because now we're going to have a situation where you're going to have a number times the x squared. And in the future, you're going to be adding things. But here's the key. There's only one added layer. Whenever you're going to solve an equation, you want to get the x squared by itself. And then we'll square root both sides. Now, one quick side note. Because this is the one section that's different than all the others. We learned 3 other ways to solve quadratics this chapter, and in all the other cases, you have to set it equal to 0 first. We stressed that in the first 2 sections. Having said that, the reason this is different is because a piece is missing. Note that in all these examples that we're doing today, there is no x term. Okay, there's an x squared, and there's numbers, but there's no x. It's when the x part is missing that you just want to solve it for x squared and then square root both sides. Okay, so in number 1, when it says what are the solutions to the equation 7x squared equals 112, again, I can't square root until I get the x squared by itself. So since it's 7 times x squared, divide both sides by 7 first. I get x squared equals 16. And now we do what we did on the previous side. As soon as the x squared is by itself, I square root both sides. Gives me x equals plus or minus the square root of 16, which is plus or minus 4. Don't forget the positive negative. Okay, again, Pearson does have that plus or minus symbol, or you could type it in as 4 and negative 4. Either way is fine. All right, number 2 is one where we have to be careful, because on the previous side, we said if you ever have x squared equals a negative, it's going to be no solutions, because you can't square root a negative. So some students would accidentally say right now for number 2, there's no solutions. The problem is, be aware, because it's not just an x squared right now. It's a negative 3 times x squared. So you can't determine that until you get the x squared by itself. So I would actually have to divide both sides by negative 3. That gets the x squared alone. Negative divided by a negative is positive, and 24 divided by 3 is 8. Now we're going to see where yesterday's lesson comes in. Okay, we said to solve for x, we would square root both sides. We get x equals plus or minus the square root of 8. Now our example so far, it's been a nice, neat, perfect square, like the square root of 16 in the previous problem. Having said that, the square root of 8 is not a perfect square. For these types of problems, once you square root both sides, you are going to simplify the radical, like we learned yesterday. So I would first rewrite this as plus or minus the square root. I know that 8 is 4 times 2. So I can rewrite it as the square root of 4 times the square root of 2. And then my final answer is plus or minus 2 root 2, because the square root of 4 is 2. So this is where our examples are going to start to have some things where we have to simplify the radical. Every once in a while, when it's not a perfect square, you could be asked the follow-up question of if it's not an integer, decide what 2 integers it's between. So like in number 1, we had 4, right? Positive and negative 4. In this case, because it's 2 times the square root of 2, and the square root of 2 is less, it's between 1 and 2, right? It's like 1 point something. It's going to be between 2 and 3. Okay, so 2 root 2 is somewhere between 2 and 3, and negative 2 root 2 is between negative 2 and negative root 2 and negative 3. So if you're asked that follow-up question, the number in front times the radical is going to help you figure that out. All right, but so again, if it's a times x squared equals c, we divide by that number in front first. So go ahead and pause the video, try this one. Number 2 might be a little tricky for you since there's a fraction, but it's good practice. Hopefully you realize you needed to divide by 5 first here. You get x squared equals 25, square root both sides, and you get x equals plus or minus 5. Notice I skipped the step of rewriting it as x equals plus or minus the square root of 25. The more you practice, the more you're able to skip that step. However, you want to be careful not to forget the plus or minus. Now, when we have a fraction attached to the front, we have 3 options, I guess. Okay, it's negative 1/2 x squared. If we follow what we've been doing, hopefully you thought about dividing by negative 1/2. X squared equals, but now I have to know how to divide by fractions. Now, one option, though, I said we have 3. One option is you, in theory, could do negative 36 divided by negative 0.5 on a calculator. Okay? Otherwise, if we have something divided by a fraction, it's good review. Negative 36 is like negative 36 over 1. Remember, when we divide by fractions, it's the same as multiplying by the reciprocal of the bottom. So negative 36 divided by negative 1/2 is positive. Sorry, I put a negative because a negative divided by, or negative times a negative is positive, 72. So we end up with x squared equals positive 72. Now the other option, just as a side note, if you had negative 1/2 x squared equals negative 36, some of you may have been taught or remember that to avoid having to go from here to here, we could, if we have a fraction in front, you can always multiply by the reciprocal of that fraction on both sides right away. Okay, because that cancels it out. It's another way to do algebra, but sometimes I find with students who have a harder time with math, that seems like a different strategy than what they're used to doing. So stick with what's easiest for you. All right, but once you had x squared equals 72, should have square root of both sides, x equals plus or minus root 72. Then hopefully you recognize this as not a perfect square, but as something you could simplify. I believe we even did this one yesterday. It is 36 times 2. So plus or minus root 36 times root 2. Root 36 is 6. So you should have gotten plus or minus 6 root 2 for full credit. Now again, if we wanted to state the 2 integers that the solution is between, because it's a 6 in front, we would say it's between 6 and 7. That's not really a super important thing, but it just comes up every once in a while. All right, so now we get the hang of it, right? We have to get the x squared by itself. So there's only one last piece we have to look at, and that is sometimes you're going to have what we call everything going on. You're going to have an ax squared plus some other number equal to a number. But notice there's still no x in there, no x to the first power. Okay, so our strategy does not change from what we just said. We're still going to get the x squared by itself, and then we're going to square root both sides. The only difference is I have to do 2 steps of algebra before I can do that. So how do I solve 3x squared minus 5 equals 22? First, I add 5 to both sides. 3x squared equals 27. Now we have a problem like on the previous slide, so I have to get the 3 to the other side. I divide by 3. I get x squared equals 9. Now we have the first version we started with. So now to solve for x squared, I square root both sides, and I make sure I get the positive and negative number because both 3 times 3 is 9 and negative 3 times negative 3 is 9. Okay, go ahead and pause the video. Try both of these and then unpause to see how you did. First one here, you should have subtracted 19 from both sides. I got negative 5x squared equals positive 125. But then I divided by a negative 5. I got x squared equals negative 25. Remember, it's at this point, when I go to square both sides, I have, sorry about that. When I square both sides, I have the square root of a negative, which means I can't do it. So there's no real solutions or no solutions. Hopefully you were able to recognize that and stop there. So in number 2, hopefully you subtracted 17 from both sides. Then you would have gotten to 3x squared equals 192. Divide by 3, and you get x squared equals 64. Square root both sides. Perfect square of 64 is 8, so it's plus or minus 8. Okay, so that's the algebra we have to be able to do. We're going to finish up just by looking at a real world example. We have a right triangle right here. Okay, so perfect right triangle. Cell phone tower has a guy wire. It's just a wire that goes from here to the ground to support. The height of the tower and the distance from the tower to the wire is secured on the ground are the same distance. So this is x and this is x. Now you'll hopefully remember the Pythagorean theorem. And in the Pythagorean theorem, we learned that in a right triangle, you can take a side squared plus side squared, and it equals the hypotenuse squared. Okay, it's really a squared plus b squared equals c squared, but where a and b are the two sides. So in this case, my side lengths are x, so x squared, and x. So x squared plus x squared equals 200 is the length of the hypotenuse, so 200 squared. If we combine like terms, we have 1x squared plus 1x squared, which is 2x squared. If in my calculator I do 200 times 200, because that's what 200 squared is, I get 40,000. Now we're going to solve like we learned today. We divide both sides by 2. We get x squared equals 20,000. And then we square root both sides. So I get x equals. Now, for this one, you will have one of these in your word problems, and they actually want you to simplify the radical. They do not want a decimal. Okay, so you would take the 20,000, and I see 4 zeros, which makes me know that I can break it apart as 10,000 times 2, because 10,000 is then 100 times 100. I wouldn't usually have to show it that way. I could just take the square root of 10,000, but if I have two 100s, that gives me 100 and on the outside root 2. Now you might say, well, Miss Leminski, when you did this step, why didn't you take the plus or minus? I should have mentioned it as I did that step, but this is a real world problem. I'm finding the length, and length can't be negative. So the one time in math where we ignore the rule of taking the positive and negative when we square root both sides is when the negative answer doesn't make sense. I can't have a negative length. So I only choose the positive when I square root both sides here. Okay, so this problem is in feet, so it's 100 root 2 feet. Now I will say, Pearson, the word problem I put in there, they want it like that. Having said that, typically speaking, that doesn't have a whole lot of meaning to me. So I would do 100 root 2 in my calculator, and I got about 141 feet. That has more meaning to me than 100 root 2. Okay, so to summarize, again, you're going to have 3 types of problems. Just x squared equals a number, and then you could have all the pieces going on. We show some examples here, and then don't forget, if you have a square root of a negative, it is no solutions. Okay, remember, if you have solutions, we have to use the plus or minus to indicate that there's a positive and negative. Here's the note sheet with all the examples we just went through if you want to write anything down that you missed. Otherwise, you can look forward to the 9-4 warm-up tomorrow and maybe get started on your Pearson practice.